Hello folks. Finally I'm back with another video, a new video, the first one in 2021. I'm really sorry for the delay, but yeah, there's always something happens in life, and for me there were some issues last year, so I wasn't able to produce any videos. And in the beginning of this year, I started a collaboration with a telescope manufacturer here in Germany with Teleskop-Service, and now I'm also producing videos for them, and I'm super happy about it. But that also means that there's less time available for doing personal videos. But I will try to add some more content over the year, definitely more than last year. And today I'm not sharing a live session from the telescope or the observatory with you, but an image processing. I decided to show you this one here because I showed this final image on Instagram a couple of days ago, and there were great responses to it. People were super happy with the result, and I want to share how I process such an image from the raw data from the telescope with different color channels and something into one single color image. This is what's about tonight, and I'm really happy that you joined me. If you have any questions about my processing or comments or something like that, feel free to drop me a comment below, and I would really appreciate it, and I will try to answer your questions. Okay, so now let's get started. I already prepared some things, but I want to show you at least the steps overall. So just let me reduce the size here a bit. I'm sure you don't need to see me that large. So first of all, I want to show you just quickly how my raw files look like. So for this I go for just a random luminance frame, so the broadband signal information, and I choose the raw file, the calibrated one, the cosmetic corrected one, and the registered one. Where's the 20? So now let me talk you through these 4 images here. First we have our luminance frame. This is what comes directly from the telescope, from the camera. And yeah, this is just a random frame, but I always choose the number 20, so it's in the middle of the imaging session. And what we can see is that there is a vignetting occurring here, but that's okay. That's the optic. Every optic suffers from that, but depending on the amount of vignetting. And I have to mention, it was around full moon, so this was also the reason why I choose to go for M92, a very bright object in the sky, because these other things, my little tiny galaxies, are just not, I'm not able to capture it with a highly illuminated sky. And I was also not sure what the seeing does at this night, so I just wanted to get some data and do some easy things over this night. Okay, so this is a luminance frame, single exposure, and the next step in the image processing is always the calibration of such an image, and this is done by a bias correction, a dark frame, a master dark frame, and also a master flat frame, and that produces an image like this. So the idea is to reduce the noise in the background with the dark frame and the bias, and this is working. Yes, it's working. It's not clear in any way or totally flat, but no worries about that. But what is clearly to be seen is that the image is really flat now. There are no dust donuts, no vignetting anymore. There may be still gradients in it, of course, because with this flat frame we correct only the instrument itself, not the sky. And what is still in there are some, yeah, here you can see them, hot pixels. These are just random pixels that are not corrected by a dark frame, or they are just too bright, so the dark correction will not work. And when doing many sub-exposures, in my case 40 exposures per channel, and use dithering, then you can just ignore these hot pixels. They will be rejected by the subsequent rejection algorithm. But if you want to ensure that the image is as best as it can, I do this in this way. You can apply a cosmetic correction. This is a rather default process in Pixinsight, and this process checks for very small single pixels that are hot, so that means white, completely saturated, and it will replace them by the average of their neighbors, average of the surrounding pixels, and then you can see there aren't any hot pixels anymore in this image. And this is what I've done for all these 120 subframes. And the last step in this process is to align all the images to each other so that the stacking will produce a perfect stack overall. But this is not very clearly seen in such a frame. Yeah, here you can see there's a black streak, so there may be a rotation corrected in this single frame here. So now, the problem with this object and this exposure set is that these 120-second exposures leads to a saturation here in the core. All these stars here in the core are saturated. Let me just go back to a linear frame. Here you can see all these core stars are saturated. So normally when having stars in an image, that is okay, because you don't focus on or concentrate on the stars. But here, this is our main subject, so this is not so nice to have them saturated. And I recognized that in the night when capturing all the images, so I decided to spend another night to do some shorter exposures. 30-second exposures then, the night after. And with this exposure set, I was able to get something like this. This is the luminance stack over all luminance frames with 30 seconds. And here you can see the core stars aren't saturated. But with 30 seconds the darker structures are not that prominent. And what we want to do is we want to add the 2-minute and the 30-second exposures in a proper way. And this is called, you may know it from photography, this is the dynamic range compression or high dynamic range. And there's also a process in Pixinsight in the image integration. It's called HDR composition. And here we can add the two different exposures. First the 2-minute and now the 30-second. We have to repeat this for all the channels, and we choose to use half of each image. We don't need the masks. We also don't need a 64-bit image. This is a 12-bit CCD, so no point about that. We want to reject black. Yeah, that's everything okay. Okay, so that went pretty good. So now here we have our HDR composition. So dark structures are still there. Here are some faint little galaxies in the image, which I really like. But also the core isn't saturated anymore. Here you can see the effect of this HDR composition. So working very nice in the way I want it. So I will repeat this for the other channels. I'll be back in a moment. So, okay, I repeated this HDR composition now for all the color channels. So this was all pre-processing, all the steps to being able to create a color image. And now it's time for the next process, the LRGB combination. And here we just add our single channels, LRGB. So for now I just keep this default here, no changes in that. You can fine-tune your color combination with that, but I don't think this is needed. So let's have a look. Okay, so what can we see here? In the corners and the borders we have drizzle artifacts, that's okay. Here's this area is darker. Here's also a gradient going on this side and here. But anyway, the image looks really nice, really flat. There may be a large gradient, darker from here to brighter to here. That's okay. We can easily correct this with the next process I want to use, and this is the first of all let me just crop the image by a tiny amount, because the thing is it's really difficult to get rid of these small gradients on the very edge of the image. Normally I would try this in Photoshop, to be honest, and just increase the brightness with a brush or something like that. But I will try to process it completely in Pixinsight. No Photoshop involved today. So let's just let me crop it so we can get rid of this drizzle artifacts. That's always needed, but it's fine. We talk about a 16 megapixel image, so cropping is not an issue. So, and I think I will crop it this way so we can also center the primary object a bit better. And now we get rid of this dark thing here and this structure. I can live with that, that's okay. If you have to keep the full frame, then you may have to repaint something or create different models or very precise models with the background extraction. So background extraction, yes. Let's just go for dynamic background extraction. Why dynamic? I can show you the difference. With the automatic background extraction, you have to be very careful with your settings of that process, because it will take some of these stars into account, and some of these fainter outer structures, and this will create a weird circular donut shape background model. That's always the case. You can handle this by, as I said, testing around with the parameters, but when we just use the default, I'm quite sure that this weird donut artifact will happen. So yeah, it's not that weird, but you can see it increases the brightness in the corners. This is just wrong because we have this vignetting, and it increases also the brightness in the center, or it models the brightness to the center. And the result will be something like that. Okay, it's not that bad, to be honest, but this is not precise. Definitely not precise. So, and I know this behavior, so I always go for dynamic background extraction with such a target. And what we do now is we just place a couple of points in the image that shouldn't be too much because it is flat. there are no things that this process has to worry about, and also not to the very corners, only this way. I definitely want to capture this strong left to right gradient. That's important for me. That's what I want to achieve. And we do it something like this. And maybe also a bit more in the to the object itself, but we have to take care to not use any stars in this. Yeah, maybe also one here, and yeah, let's give one here. Something like this. So, don't know, 1 minute or so. And let's have a look at our background. Whoa, that's the background model, and that's exactly what I expected. This dark left to right gradient here. Let's have a look. This is what this process will produce then. So the vignetting is corrected. It was only very slight vignetting remaining in this cropped image, so no problems with that. Great result, I think. So what we now also can do, now first of all I will save this. Let me create just a new folder. I always try to save the steps of this image at some time, and this one here is the raw HDR stack M92. Okay. So, and what to do now? In the next step, I want to create a more realistic color model to it, and for that I use a photometric color calibration. Oops, no, that's not working. This method uses real star colors, known star colors in the image, to produce a calibration curve which then is applied to the image. But to know where we are in the sky, we have first to solve the image. These are the coordinates, the date just roughly, something like that, and the parameters. Unfortunately, this is no STAB or astrometry.net, so this plate solver needs a good estimation of the position and your imaging data, so you just can't solve anything, or very distorted images are not possible to solve with that. But of course, with the observatory and my setup, all these things are known, and we can try to apply this. Okay, here we are. This photometric color calibration script does also give you an idea how good the data is matching to the real star colors, and this looked really good already. So now, our image. What to do next? The next thing would be we should apply a stretch to bring it from the linear to a non-linear appearance, and there are multiple ways to change the intensity, and for this particular type of image I would always give the masked stretch a try. You can also use just a histogram stretch, but the masked stretch is much more useful for that bright to dark range, for that high dynamic range of the image. And we left all this default background, target background 0.125 is good. Yeah, so give it a try. So the result from just a simple masked stretch, and for me this already looks good, and here you can barely see also some colors, which is nice. The nice thing with this mask stretch is it tries, at least it tries to protect the stars, and this is, yeah, it looks weird because they are, as I said, saturated, but with the next step, a curves adjustment, this will look a bit better, I hope at least. So I would first try to change the saturation of it. So there's no mask saturation, so I don't know if there's any mask saturation process. So we have to create our own mask. Why a mask? Because I don't want to increase the saturation of the background. I want the background exactly the way it is now, gray, a real dark gray, because that should be a sky color, and I don't want to increase the noise. So I create a mask with only the stars. Oh, you can see there's still something in the background, still a gradient, but I can't see this in the image. But such tools can reveal this. So I would say we can go with something like this, but a more blurry. Yeah, that is okay. And now let's create this mask and apply it to the image. So all changes now are affecting only the stars here in the image. All the red areas from the mask are protected. So let me just hide the mask that you can see better what's going on, and on too. So there are two ways of changing the saturation. You can use the color saturation or by a curves transformation and then choose saturation. In my experience, of course, this is depending on the brightness of the object. It is more subtle. And applying this, and it's barely to be seen in the preview. Just apply it here. Ooh, that's nice. So what you can see, there are very bluish stars, maybe because of our very bad blue data, because the blue stars are a bit bigger. That can be the reason. So therefore I'm going to use another process, and this is the color saturation, because with this process you can hold the blue tones like this low and increase only the others like the red and also the greens, but there's no green in such an image, and that will result in something like this. That's okay. Let's apply it. Look, yeah, we can give it another one. You should be really careful how much of this changes to apply. You can also increase the amount in a single step highly if you want, but it should be not needed, because then it looks really, really weird. When I apply something like this, yeah, then artifacts will be created from that script, also because of the mask. So let's just stay to this one. It's not that super colorful, but I like it more in this way. So what I also can do now is a bit of noise reduction, but there is not much. Unfortunately, I just deleted the mask. Test. So I reapplied the mask for the noise reduction, but now we have to invert the mask because now we want to protect the highlights. They don't need a noise reduction, but we want to apply the process on the background. To be honest, there is not much to do. I like this slightly crispy background more than a completely washed out flat background, to be honest. That looks more convenient to me. Now let's just try a TGV denoise, but only with a very small amount, very small strength. Okay, all channels are done. This is a very small amount and I like that. I like it. So now we can drop our mask. And I would say, just let me clean up this workspace mess here. Oh no, just one last step. I want to change the brightness because I think the background can be a bit darker, just a tiny amount darker, something like that. Not too much. It shouldn't be really black because the sky is not black, at least as we can see it. So and then we can increase the midtones, and this is this all the outer regions of this cluster here are now really improved, but we reduce the highlights, the core, but you can see my changes are very small to not overdo something. Here you can see what happens then. It's just bright, this is just weird. So very small changes here, and more from this outer area here. That is, I found this is great. Yeah, something like this. Oh no, not this. Yeah. Let's give this a try. So here it is. This is my final image, I would say. At least as Pixinsight is involved now, we can fine tweak it in Photoshop, but honestly this is not needed. It's a really nice image. And this is my final result for now, and thank you very much for staying that long with me. I hope this was of interest for you, and if it was, or even if it's not, please drop me a comment below, give me a thumbs up if you want. I would really appreciate it, and I want to hear your opinion on that, if you like that format, if you like seeing other image processing videos. There's much more to tell you, especially with Pixinsight. For example, let me show you my current wallpaper. This is processed from a dataset, processed by me of course, processed from a dataset from Telescope Live, a remote telescope provider, and yeah, you can see this is a different story here. Narrowband images, very colorful and powerful. That's also possible to tell you something about that. So again, thank you very much and see you soon. Bye bye.